Integrated technology systems for factory automation and process control. So let's talk about the integrated technology systems available for factory automation and process control. In today's extremely competitive market, increasing demand for high quality goods are at viable pricing has led to the evolution of using integrated technology systems in manufacturing industries. To address this challenge, a wide variety of means were tried out. The most remarkable and the influential move was the development of industrial automation. This project aims at developing an understanding of the integrated technology systems used for automation and various process control systems. Industrial automation is nothing but automation of manufacturing, quality control, and material handling processes in order to increase the product quality, reliability, production rate while reducing production and design cost. It also facilitates in developing innovative and integrated technologies for factory automation and process control. Industrial automation will create explosive growth with the advancement of automation technology with new inflection points such as nanotechnology, assembly points, Internet of Things, MEMS, machine to machine networking, etc. It is considered as the second phase beyond mechanization in the space of industrialization. By implementing integrated technologies in factory automation, it will also replace the human decision making skills as well as manual command response activities with the use of these mechanized and logical programming commands. Even though there are a lot of disadvantages in using automation, the advantages stand out in the larger scenario. The most generally used systems in the integrated technologies include the programmable logic controllers, standalone uh, input output modules in computers. The most common trend seen is the increased use of machine vision systems to provide automatic inspection and robot guidance functions. Process control checks on the industrial processes so that it is carried out efficiently and effectively. The future of industrial automation belongs to nanotech, complex, adaptive systems, and going wireless. So let's talk about the previous researches done on factory automation and process control. Integrated technology systems have advanced over the years and plays a key role in today's manufacturing and production industries. The organization now are adopting latest technologies and smart manufacturing activities to use the resources optimally. According to the studies conducted by Global Forecast Analysis, the automation system offers great advantages such as reduction in industrial waste, reducing cost, faster production, as well as easier production and production monitoring and management. The emphasis by the market players on energy saving and efficiency improvement is driving the market forward. Automation and factory control divided on the basis of technology, field devices, geographical applications, and technology services. Segments. The technology services and segments include industry control like supervisory control and data acquisition, the SCADA systems, program logic controls, DCS, distributed control systems, manufacturing execution systems, etc. Based on the research conducted by Hosino in 2010, he took a constructive approach to the coordination problems from a viewpoint of flexible automation in industrial applications. This approach also proposes the operational techniques that are capable of applying to the robotic systems in consideration of the actual robot's performance, systems layout, operation task, and then synthesize each solution through the simulation experiments. According to the studies conducted by Thurin in 2014, an inductive research methodology has been used which goes through the current trends in industrial automation. Based on the thesis submitted by John L. in 2006, technology is utilizing more innovations that increases productivity, reduces operational costs, and shortens lead time to the customer delivery. Now let's talk about the backbone of this research project, the methodology. Industrial automation is a wide phrase which includes all sciences and technologies integrated to implement an industrial system for automation and process control. It includes a wide variety of systems coming together for a final outcome. The main focus of the automation system is on the control systems, control languages, control like the algorithms, and applications involving the interactions with the other systems. Some of the main components of the automation systems are mentioned below. Field devices. These include physical sensors and actuators, embedded systems. These include embedded devices such as smartphones controlled by internally by a dedicated microcontroller, cyber physical systems, Internet of Things, business enterprise system, and industrial automation integration. The operational technology and informational technology continues to grow with tighter integration. The significance of tight integration between the plant floor and enterprise business system is accomplished for improving manufacturing efficiency, quality, and flexibility. This is the next analytical step of business system integration with all systems involving the real-time synchronized operations including PLM, ERP, asset management, process optimization, etc. Beside is an illustration of the business enterprise system and how the industrial automation is integrated into it. Automation and SCADA systems. Another approach to integrating technology is the use of various automation systems and supervisory control and data acquisition systems, also known as SCADA. This particular system is also a subtype of industrial control systems. They are used to monitor and control systems such as power grids, oil pipelines, sewage, and water distribution systems, and are also used in the food and pharmaceutical industry. SCADA systems are distributed and often highly interdependent systems which makes use of the control center to centralize the control functions. Components of a SCADA system. A traditional SCADA system consists of field instrumentation, remote terminal unit, master terminal unit, and communication systems. Internet-based SCADA system consists of networking and web technologies. The figure the figure represents both the traditional as well as the web-based SCADA system. Components of a traditional SCADA system. The field instrumentation. Field instrumentation refers to the sensors and actuators that are directly interfaced to the plant or equipment being controlled and monitored by the SCADA system. These field instruments convert physical parameters to electrical signals readable by the RTU unit. Remote terminal unit. The RTU is a controller that is interfaced to the field instrumentation which is connected to the equipment being monitored and controlled. Initially, they were developed to be used as electronic black boxes. RTUs perform the function of PID controllers, fluid meters, program logic controllers, etc. It is generally available in two types as single board and modular unit having different specifications. Master Terminal Unit. The MTU is a principal station or a host computer acts as a centralized controller for the SCADA system. It could be a single computer configuration or a network of computer workstations. It will also have auxiliary devices such as printers, loggers, backup memories, etc. The MTUs are responsible for gathering field data from the RTUs and processing the information to generate the necessary control actions. It also acts as a messenger that requests updates from RTUs at fixed intervals. Communication. Communications Communication is the spline of the SCADA technology. In order for a central MTU to communicate with the RTU that is located at distant locations or with various computers and systems that are located within the corporate network, a communication link must exist to transfer data from one location to another. A illustration of the traditional SCADA system is shown in the figure beside. Internet-based SCADA system consists of two main elements, networking technologies and web-based technologies. The Internet is purely a connection of regional wide area networks. To analyze the networking technologies, international organizations use reference models. The networking model consists of 7 layers like the physical, data link, network, transport, session, presentation, and application layer. Web technologies. Web technologies also play a crucial role in implementing the SCADA systems. The two main components are the web servers and web clients. A web server is simply a computer designated to send out data in response to the request, while web clients are servers that sends requested information to the clients or browser software. Robotic batch manufacturing system. The introduction of industrial robots such as material handling robots and material processing robots have facilitated the material transportation at a faster pace with accuracy. Materials are transported to the designated workstations by a mobile MHR and then processed by MPR with the weighted equipment. This type of equipment manufacturing system is known as robotic manufacturing, batch manufacturing. In a robotic batch manufacturing, the MHR moves cyclically from one station to the other station to execute transportation task assigned. The material processing robots receives the task information from the material handling robots and executes the tasks at each station. This provides an effective point to prove the need for integrating technology in factory automation and process control. Results and discussion. Through the research studies conducted on SCADA systems, we came to a conclusion that web-based SCADA is a system that uses more than one internet technology. The technology used includes communication technologies, software programming technologies, web-based technologies. The key goal of applying internet-based SCADA system is to utilize the internationally accepted standards and technologies to achieve the monitoring and control functions that a traditional SCADA system offers, but within a lower cost. This will usually result in a better interoperability between different system components, easier dissemination of information to various applications, external systems, and a unification of human machine interface through a standard web browser. The main objective of implementing the internet based SCADA system is to influence the existing technology and to apply them for process automation. The internet usually uses open standards, which is considered as being a major advantage for web based SCADA over the traditional systems. Talking about the robotic batch manufacturing system, which is the automation of highly flexible manufacturing systems with multiple robots, the existence of bottleneck causes serious issues. There are certain challenges to meet in order to implement the robotic batch manufacturing system, such as the bottleneck prevention and restraint. A constructive approach was taken to solve the multi robot coordination system, though simulation experiments and integrated operation technique was identified as the most efficient combination. There were three main operational techniques like route planning, operation dispatching, and multi task assignment tested for the robotic batch manufacturing system. Coming to the conclusion of this project. Through this work, we have tried to study about various integrated technology systems for factory automation and process control. Research work was focused on two main concepts in factory automation and process control. The main hypothesis being concentrated on the internet-based SCADA systems and then robotic batch manufacturing system. Through our research, we came to the conclusion that there are scopes for improvement in the internet-based SCADA systems, particularly in interoperability and cost effectiveness. However, internet-based SCADA systems are still less reliable and secure than the traditional SCADA systems. In addition, internet-based technologies are evolving rapidly, and the strategy of how to implement them in the process automation would require the group effort of academia and industry. For the automation of highly flexible batch manufacturing systems with multiple robots, the existence of a localized bottleneck causes serious issues. Through simulation experiments, as an integrated operational technique, we finally identified the most efficient combination of operational techniques among the combinations of the reactive cooperation. As for the feasibility of the proposed operational techniques to the actual system, the computational cost of each technique was successfully kept low so that the integrated technique does not affect the robot's coordination.